So in this video we're just going to look at solving simultaneous equations and what happens when you have parallel lines. So we have two equations here, one of them in gradient intercept form, the other one in standard form, and I'm going to use the substitution method to solve these. Using the substitution method means I don't have to rearrange both equations to the same form, but also I just prefer the substitution method. The other benefit is because equation 1, which I'm labelling now, equation 1 is already solved for y, we can just substitute it straight into the other one, so we can substitute it into here. So, always good to label your equations. Another thing they don't do in the book, well, they sort of spell out what they're doing in the book in the left-hand column, but in your working, you should really be saying what you're doing. So we can say first sub 1 into 2. We've told the person who's reading our work that we're substituting equation 1, all of this, into equation 2. So wherever there's a y in equation 2, we're going to be putting half x plus 3. Okay, so sub 1 equation 2, therefore we have x minus 2, subbing in our equation 1 right hand side, half x plus 3 in brackets, minus 6 equals 0. It's 0. So we've got here, x here, minus 2y, this is 2y, minus 6, don't forget to put the minus 6 in, you might get excited after you've just filled out some brackets and forget to add the minus 6, and then the right hand side is minus 0. So, what we do then, next, therefore, we say x is negative, and we expand the brackets. So, 2 times a half x and negative 2 times 3. Sorry, negative 2 times half x and negative 2 times 3. So, negative 2 times half x is negative x, and negative 2 times 3 is negative 6. And we have negative 6 again, so don't forget this negative 6 again, it's easy to do, equals 0. Now let's collect like terms. Well, x minus x is 0, so they're gone. And negative 6 minus negative 6 is negative 12, equals 0. Make sure you're careful with your signs there, because it might have been easy to go x minus x is 0 and 6 minus 6 is 0 and just forget that this is negative 6 minus 6, so it's actually negative 12. And if you did that, you could end up with a true statement which says 0 equals 0, which would be wrong in a sense. What we've actually got, the negative 6 minus 6 is negative 12, and we've ended up with this statement at the bottom which says negative 12 is equal to 0. Now we know that negative 12 is not equal to 0. That is a false statement. An important thing is, if you read this you might go, what? I've done a mistake or something like that, or that's a bit weird, that doesn't mean anything. What it means, so the one important thing in maths is no mathematical statement is meaningless. It all has meaning. In this case, this false statement means that there is no simultaneous equation for these two lines. The lines are actually parallel, so they never cross. So when you have parallel lines and you solve algebraically, using the substitution or elimination method, you'll come up with a false statement, and that means that they are parallel lines, they never intersect. And if we quickly rearrange equation 2, we'll have negative 2y, let's try that again. Let's move y to the other side first, so x minus 6 equals 2y, and we'll just switch them around, so 2y equals x minus 6, and then, oops, keep this separate from the other rubbish, divide by 2 both sides, y equals half x minus 3. So if you look at this equation, gradient is half, and our original equation, gradient is half. One goes through the y-intercept positive 3, one goes through the y-intercept negative 3. So you can see, once you arrange them into the same form, they are actually parallel lines. So the important thing is, if you come up with some weird answer like this, well, it's possible that they're parallel lines. Maybe rearrange your equations and check your gradients. The other possibility is you've made a mistake somewhere along the line. So maybe if they're not parallel lines, go back and check through your working to see if you've made a mistake.